This video explains microservices architecture. We will explore the concept of breaking monolithic applications into smaller, manageable microservices. Let's begin by understanding what microservices architecture is and why it's becoming increasingly popular in modern software development. Let's understand what a monolith is. A monolith is a single deployable unit where all components are tightly coupled and deployed together. All functionality exists within one codebase and runs as a single process. As you can see in the diagram, all the layers like user interface layer, business logic layer, and data access layer reside in one place. In short, it's one big application. Monolithic architectures, while simple to start, present several challenges as applications grow. First, scalability becomes an issue as the entire application must be scaled, even when only one component needs more resources. Second, there is technology lock-in, meaning you are stuck with a single technology stack, making it difficult to adopt new technologies. Third, deployment risk is high, as a single change requires a full application deployment, increasing the risk of system-wide failure. Finally, large teams working on the same codebase create coordination overhead and conflicts. Microservices are small, independent services that communicate over well-defined application programming interfaces, or APIs. Each service is independently deployable, scalable, and maintainable. Think of them as building blocks that make up a larger application. Each service has a specific business functionality. Examples are user service, order service, payment service, and inventory service. Microservices architecture offers several benefits. Technology freedom is one of the key advantages. Each service can use a different technology stack, allowing teams to choose the best tool for the job. Also, services can be scaled based on demand. This ensures efficient resource utilization and cost savings. Breaking down a monolith into microservices involves transforming a large single application into a suite of smaller, independent services. As you can see, the monolithic application is broken down into user service, order service, payment service, and inventory service. There are a couple of decomposition strategies. Firstly, split based on business capabilities and bounded contexts. Secondly, each microservice owns its data and database schema. This ensures that each service is independent and can evolve without affecting others. Microservices communicate with each other using various patterns. One is synchronous communication, such as using representational state transfer, or REST APIs, and Graph Query Language, or GraphQL, for real-time request-response interactions. The other one is asynchronous communication, uses message queues and event streaming for decoupled interactions. This allows services to operate independently and handle failures gracefully. Here is a basic implementation example using Flask, a Python web framework. This code defines a simple microservice that returns a list of users. The route/users returns a JSON response containing a list of users. The application runs on port 5001. To summarize, microservices provide scalability and flexibility, but add complexity. Start with business domains when decomposing monoliths. Understanding these key concepts will help you make informed decisions about adopting microservices in your projects. If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.